Welcome friends once again to the YouTube channel Maths by Sanjay Agarwal. Sanjay Agarwal Maths Classes. So we are doing vectors, that is a chapter of class 12 Maths. It is one chapter which is independent of the previous chapters like integration, differentiation, relation and functions. So this chapter you can start anytime while studying for 12th Maths, because it's not lagged or connected with other chapters. Like if you do integration, you need to do differentiation first. You cannot do integration prior to doing differentiation, but vector is one chapter which you can do independently. After vectors is coordinate geometry, three-dimensional coordinate geometry. For that you need the knowledge of vectors. So you cannot start three-dimensional coordinate geometry without learning vectors, but vectors you can start any time of the year. So we have already covered 4 lectures. I call them as episodes 1, 2 and 3 on vectors. And if you are joining for the first time in this video, you have to watch the previous ones so that you can understand what will be taught to you in episode number 5. So in the last episode, we did representing every vector in terms of the endpoints of the coordinates of points A and B. And let me briefly tell you what we did in the previous class. This is A, this is B. You know the coordinates of A as x1, y1 and z1. You know the coordinates of x2, y2 and z2. So what is vector AB? All this we did in the previous class. So those who have already attended and watched and understood episode number 4, for them it will be a quick recap, a revision. So vector AB will be x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. So we did in the last class this formula. We even derived this formula. What is magnitude of vector AB? It is the square root of x2 minus x1 whole square, that is the coefficient of I, plus y2 minus y1 j y1 whole square, that is the coefficient of j, plus z2 minus z1 whole square. I speak it in a form of a poem. Is the square root of the sum of the squares of the coefficients of i's, j's and k's. Alright. Now every vector which is expressed in terms of I, j and k has both the informations very cleverly hidden in it. Its magnitude, which you already know how to extract, and the direction, for which you are still eagerly waiting when will sir tell us how to extract the information regarding the direction of the vector, but for that you will have to wait for a while. And also we did what is the x component of this vector, x2 minus x1 I cap, y component was y2 minus y1 j cap, and z component was z2 minus z1 k cap. All this we did in the previous lecture. And then we also did how to add 2 vectors expressed in terms of I, j, k, which was so quick, how to subtract 2 vectors and how to multiply a vector by a number. Now the class starts episode number 5 on vectors, carry forward from episode number 4. Now I will talk about equality of 2 vectors which are expressed in terms of I, j and k. See, in the previous or episode number 1, we have discussed what do you mean by 2 vectors are equal. 2 vectors are said to be equal when they have the same magnitude and they have the same direction. Similarly here, if vectors are expressed, say 2i plus 3j plus 4k, and there is another vector xi plus yj plus 4k, no, say zk. Now it is given to you, vector A is equal to vector B. Find the values of x, y and z. 2i plus 3j plus 4k, this is vector A. Every vector is being expressed in terms of I, j and k, and this is equal to vector B xi plus yj plus zk. Now I am going to make a very interesting statement for you. 2 vectors expressed in terms of I, j, k are, if they are equal, what does it imply? The coefficients of i's, j's and k's are separately equal. If two vectors are expressed in terms of I, j, k and they are equal, then the coefficients of i's, j's and k's are separately equal. So, x is equal to 2, y is equal to 3 and z is equal to 4. So, now you know what do you mean by equality of two vectors. Of course, that statement still stands. That is the basic statement, that if two vectors are equal, of course, their magnitudes are equal and their direction is also equal. So, now this topic is also over. You know what do you mean by equality of two vectors. I am again repeating it. If two vectors expressed in terms of I, j and k are equal, then algebraically it implies that the coefficients of i's, j's and k's are separately equal. Now, the next topic is converting any vector in a unit vector. So, you are given any vector and you want to convert it into a unit vector, of course, along the same direction. So, suppose I am given a vector A, I plus j plus k. This vector has a magnitude. You know what is the magnitude of this vector? Again, the square root of the sum of the squares of the coefficients of i's, j's and k's, which I have taken 1. So, what is the magnitude of this vector? Root 3. What is the direction of this vector? That topic still awaits. So, we will come to that topic in the next episode. So, this is a vector. Randomly I made some vector. I again repeating it. I will be repeating it many more times. Every vector henceforth given going forward will be expressed in terms of I, j and k. What is the magnitude of this vector? Root 3. Now, you want to convert this vector into a unit vector along the direction of what vector A is having. So, what you are going to do is you divide the vector by its own magnitude. You can't divide two vectors, but you can divide a vector by a number, or you can say you are multiplying a vector by 1 by magnitude of vector A. So, this is A cap. So, because it is a unit vector and the symbol reserved for a unit vector is A cap. So, what is A cap? Vector A divided by magnitude of vector A. So, now you know, if you want to convert any vector into a unit vector, simply divide the vector by its magnitude. So, what will be that? I plus j plus k divided by root 3, and now you separate it out. So, it will be 1 by root 3 I cap plus 1 by root 3 j cap plus 1 by root 3 k cap. So, it is so simple to convert any vector into a unit vector. Simply divide the vector by its own magnitude. I am hopeful that all of you have understood this point. Now, I am making another question. You are given vector A, find a vector along the direction of this vector, but not of magnitude 1, say of magnitude 5. So, find a vector of magnitude 5 along vector A. Alright. So, how do you do that? It is like unitary method. First, convert the given vector into a unit vector by dividing the vector by its own magnitude. Once you get a unit vector, multiply it by 5, scalar multiple of a vector, and you will get the vector you want to find. So, what will be the required vector now? Let me write down required in a shortcut form. The required vector will be 5 times A cap. 5 times A cap. So, convert the vector into unit vector, then multiply it by 5. So, when you multiply this vector by 5, what will be your answer? 5 upon root 3 I cap plus 5 by root 3 j cap plus 5 by root 3 k cap. We will be doing numericals on this. This point we will take up when we are doing the numericals. Alright. So, now you know how to convert a vector into a unit vector and how to obtain a vector of a given magnitude along the direction of the given vector. Alright. So, this is vector A. You know how to find the magnitude, you know how to find the direction. You know how to find a unit vector along the same direction. You also know how to find a vector of magnitude not 1, but some given number, say 5, along the direction of vector A. So now we will take up the next topic, component of the vector. I have been promising to you in the previous episode also, I will make you understand what do you mean by x component, y component and z component. So now before I take up x component, let me generalize this first. Component of vector A along another vector B. So this is the major topic of episode 5. How do you find the component of vector A along vector B? I have a keyword for this. I say drop your anchors. Now you will say, what is this? I will explain. Okay. When you have to find the component of vector A along vector B, how do you find? So how do you find the component of vector A along vector B? Drop your anchors. See here. This is vector B given to you. This is vector A. Alright. So they have certain angle between them. Now you want to find the component of vector A on vector B. How do you find the component of vector A on vector B? Drop your anchors. From here, drop a perpendicular on B. So when you drop an anchor from a C, it goes at 90 degrees angle. Drop a perpendicular from here. So this is what I mean by drop your anchors. Let me give vector A name in 2 alphabets also. A and this is B. When you drop this, let me call this as A dash, let me call this as B dash. This what you obtain, A dash, B dash, along with direction will be called component of vector A or AB along vector B. So this is the theory of component of a vector A along vector B. So remember, drop your anchors. So component of vector AB along vector B will be vector A dash, B dash. So this vector will have a certain magnitude and this vector will have the direction. Direction, as you can see from the diagram, will be same as that of B. Sometimes it could be opposite to that of B. That is the only 2 options you have. When will be the direction opposite to that of B? Let us look at this diagram. This is vector B, this is vector A and B. Now I ask you, find the component of vector AB along or vector small a along vector B. What is the keyword? Drop your anchors. So you drop your anchor here, this will be called A dash. You drop your anchor here, this will be called B dash, and this vector will be A dash, B dash vector will be the component of vector AB along vector B. So now it will have specific magnitude and the direction will be opposite to that of B. So you have only 2 options for directions, along B or opposite to B, and magnitudes you will find. So now you know what do you mean by component of a vector along another vector. Simply drop your anchors. The component of a vector is also a vector. It will have a magnitude. How do you find the magnitude? I tell you just now. And what is the direction? Direction will be same as that of B or opposite to B. Alright. So let me make another diagram for you. Instead of dropping 2 anchors, I can drop 1 anchor and save some money. Alright. How? Let us see. Now you know vectors are free to be moved in the space. So let me move this vector and make it coinciding with the starting point of vector B. Doesn't make a difference, you know vectors are, this was vector B, are free to move in the space. That's why vectors are also called free vectors, but you don't change their direction and you don't change their magnitude. So this is one vector. Okay. So A, B, vector A. Okay. Now I can do that. This is a vector like this. I just move it and bring it here. Or it was here, I move it and bring it here. Now how many anchors I will have to drop? Only 2. Not 2, sorry, only 1. So this is B dash. So this will now become the AB dash in this diagram will be component of vector AB along vector B. So what is the direction of the component of vector AB along B? Same as that of B, you can see in the diagram. And what will be the magnitude? That is what I am going to tell you. But before I tell you how to find the magnitude of the component of one vector over another vector, you should know the concept of angle between two vectors. I'll come back to this diagram once I finish explaining you what do you mean by angle between two vectors. Alright, angle between two vectors by definition is never more than pi and less than 0. So, the minimum angle will be 0 radian, angle in radian is 0 or 0 degree, or maximum pi or 180 degrees. When two vectors are pointing in the same direction, the angle between them is 0. When they are pointing in the opposite direction, the angle between them is pi. Otherwise, it will be between 0 and pi, but it won't be more than pi, like 210 degrees, 270 degrees, 135 is possible, yes, but not more than 180. So, angle between two vectors is always between 0 and pi. So, how do I find angle between two vectors? Suppose this is a vector and this is another vector. Alright, this is a point of intersection. This could be the angle between the vectors and this could be the angle between the vectors. Suppose this is 60 degrees, so this will be 120 degrees. So, which is correct? Is this correct or both of them are correct? See, both of them are not correct. I don't want two answers. We don't want any ambiguity. Angle between two vectors will be always a unique number, unique angle, not two angles, this or that. Alright. So, this is 60 degrees, this is 120 degrees, alright. So, what you are going to do is angle between the vectors here will be 60 degrees, alright. Theta will be 60 degrees, not 120, but you will say, sir, both are between 0 and 180, so why not 120? When you are finding angle between two vectors, at the point of intersection, both the vectors should be leaving, not one vector arriving and other leaving. Either both the vectors should be arriving at the point of intersection. So, this is also correct. This vector is reaching the point of intersection, this vector is also reaching the point of intersection. So, this is a correct angle between the vectors. Or from the point of intersection, this vector is leaving, this vector is also leaving, this is also correct. If you look at this, at the point of intersection, one vector is approaching, but the other vector is leaving. So, that is wrong. So, when you are finding angle between two vectors at the point of intersection, both the vectors should be arriving or both the vectors should be leaving. If one is arriving and one is leaving, that angle is not correct angle. So, you got it? Now, let me make another diagram like this. This is vector A, this is the point of intersection, this is vector B. Now, this is also the angle between the vectors, this is also angle between the vectors. Both are leaving, this is say what 60 degrees, so this will be 300 degrees. So, what is correct, 60 degrees or 300 degrees? So, 300 will be wrong. Now, just now I wrote angle between vectors is never more than pi or never more than 180 degrees. So, this will be considered wrong, this will be considered right. So, now you know what is angle between two vectors. One more point, then I will come back to the component of the vectors. Okay. So, this is triangle ABC, this is vector BC in this direction, this is vector CA in this direction. Now, what is the angle between these two vectors BC and CA? Is it this? No, you know it is not right, because at the point of intersection one vector is arriving, another is leaving. At the point of intersection both the vectors should be arriving or both the vectors should be leaving. So, what is the correct answer? You extend BC on this side. See, vectors are free to be moved in the space. This is the vector, you draw it here. Alright, just push it further and let be this vector. Now, at this point of intersection, this vector is also leaving, this vector is also leaving. So, this is the correct answer, because at the point of intersection both the vectors should either be arriving or both the vectors should be leaving. So, at this C, when I say find angle between vector BC and vector CA, this is not the right answer. Suppose this is 60, so the correct answer will be 120 degrees, not 60 degrees. Because here one vector is arriving, one is leaving. At the point of intersection both the vectors should either be leaving or they should be arriving. So, the vector which is arriving, you just push it further up, so it will become leaving at this point of intersection. Vectors are free to be moved in the space, so it does not make a difference. You draw vector BC here. See, I will make separate diagram for you. This is vector CA, BC was here. Now, you draw it like this. Suppose I give it a symbol, single alphabet A. So, you draw your A here. So, now this is fine because both the vectors are leaving. Got it? So, I can make a very interesting numerical for you. If sum of two unit vectors, if sum of two unit vectors is a unit vector, what is the angle between the two vectors? So I will do this question with the help of I, J and K, but right now I will give you the answer of this question by concept, by geometrical representation. You are given a vector A whose magnitude is 1, you are given a vector B whose magnitude is 1, you are given a vector A plus B, that is their sum, whose magnitude is 1. Question is, what is the angle between vector A and B? What is the angle between vector A and B? I will give you a minute, figure it out and tell me what is the angle between the two vectors. Try it. So, you please get this answer. I will join the class in a minute. Try to get this answer. जल्दी बोलो यार, मैं क्लास छोड़ के बाहर निकला हूँ, बहुत है. अरे यार अजीब, अच्छा कुछ नहीं है, अभी मैं करता हूँ 10 मिनट के बाद. पागल कहीं किया. Sorry students, I had a urgent call to attend. So magnitude of vector A is 1, magnitude of vector B is 1, magnitude of vector A plus B is 1. You have to find the angle between two vectors. See, let me draw a diagram. This is vector A, magnitude 1, alright. I am not writing A, I am just speaking. This is vector B, magnitude 1, this is their sum, the magnitude is also 1. Okay. Let me give alphabets A, B and C. Vector AB magnitude 1, vector BC magnitude 1, vector AB plus BC, that is vector AC magnitude 1. You have to find this angle. Now, do you see this has become an equilateral triangle because the lengths of all the three sides is equal to 1. So, what will be this angle? 60 degrees, written in radians as pi by 3. So, lot of you will jump at the answer. So, the angle between vector A and B, both of magnitude 1, whose resultant, which means the sum of two vectors is also 1. So, our answer is 60 degrees or pi by 3. This is the wrong answer. You know why? This is not the angle between vector AB and vector BC, because at the point of intersection, vector AB is arriving, vector BC is departing. So, what you are going to do is push AB further, draw it like this. Alright. Now, at this point of intersection, this vector, which is AB, I have drawn it here, is leaving and this is also leaving. So, this is your correct answer. This will be 120 degrees, that is 2 pi by 3. So, your answer is 2 pi by 3. Wonderful MCQ for you. So, if sum of two unit vectors is a unit vector, what is the angle between the two vectors? So, angle between the two vectors is 2 pi by 3. I will do this question once again, but without making any diagram. I will do it by a formula using I, J, not I, J and K, but another formula I will use and get this answer. But if your concepts are clear of episode 1 and 2 and 3, now you understand the importance of the previous episodes, why I was emphasizing to understand vectors in terms of geometrical representation of vectors also. It's so easy to apply in some tricky situations. So, I did the entire question without using I, J and K or without using any formula except the triangle law of addition. Now, I will rub this off, come back to this, I will make a larger diagram for the current topic, component of a vector along another vector. So, in between I had to take a diversion and teach you what do you mean by angle between two vectors. Alright, so that is over. So, this is vector B, this is vector A, let me call it as in two alphabets AB, and this is the angle between the two vectors. Is it right? Yes, because both the vectors are leaving at the point of intersection. This vector is leaving, so is this vector. So, this is correct angle. So, if you want to find the component of vector A on vector B, you should know the angle between the two vectors. Now, how do you find the component of vector AB on vector B or vector small a on vector B? What is the keyword? 3 letters, 3 not letters, 3 words. Drop your anchors. So, I drop my anchor here. This anchor I save my money because I made it coinciding B dash. So, component of vector AB on B is vector A, B dash in this diagram. So component of vector AB will be AB dash on this vector B. Alright. Now since it is a vector, it will have magnitude as well as direction. So let's find the magnitude. If the magnitude of this vector, what is the magnitude of vector A? It is written like this. And what is this? Theta. So you know the triangle trigonometry, what is cos theta? Base upon hypotenuse, what is base? AB dash, the length of this line segment, divided by the length of this line AB, cross multiply, what, you know the formula, na? Cos theta is base upon hypotenuse, sin theta is perpendicular upon hypotenuse, tan theta is perpendicular upon base. Some people have curly brown hair through proper brushing. Now you cross multiply, so what will be AB dash? AB cos theta. AB dash is nothing but magnitude of vector AB dash, because magnitude of vector AB dash is the length of this line. What is AB? Again magnitude of vector AB cos theta. Magnitude of vector AB can also be written like this, because both are representing the same vector, vector AB or vector A, like this. Magnitude of A vector can also be written like simply A. Don't put a arrow, don't put the symbols of magnitude, A cos theta. So the magnitude of this vector will be A cos theta. Alright. So AB cos theta will be the magnitude of this vector. Alright. And what will be the direction? Same as that of B. And if theta is obtuse, more than 90 degrees, then direction will be opposite to that of B. So how do you find the component of a vector on a vector? Drop your anchors. The intercept will be the component of the vector on the given vector. It will have magnitude, which will be given by this formula, and it will have direction. Direction will be same as that of B if theta is acute, and opposite to that of B if theta is obtuse. Let me show you. This is one, okay, and this is another vector. Now if you drop your anchor here and here, so direction will be opposite to that of vector B. So if I redraw my diagram like this, okay, and let me draw my vector here. So this is A, this is B. This is the angle between the vectors, not this, because here one vector is arriving, another is leaving. So from this, you see this vector is leaving, so is this vector leaving. So theta here is obtuse, more than 90 degrees. So now you drop your anchor B dash. So this is it. This is the component of the vector on vector B, and you can see the direction is opposite to that of B. Now we will have two kind of numericals for finding the component of a vector on a vector. One is when the vectors will not be expressed in terms of ijk. Those questions are little difficult. And another is when they are expressed in terms of I, j and k. Then I am going to develop another formula for finding the component of a vector on another vector, and that will be very simple for you. I am just writing the formula for you. We are going to do it later on. Component of vector A on vector B. Component of vector A on vector B when they are expressed in terms of I, j, k is formula. This is the formula. So there we don't draw any diagram, we don't need theta, we don't have to do A cos theta, nothing. But this will come later on when I express the vectors in terms of I, j, k and then find the component. Right now my vectors will not be expressed in terms of I, j, k. They will be given in a different manner. When I do the numerical, you will have a feeling of that, and I am finding the component of the vector A on vector B. So the keyword is drop your anchors. So this is little confusing, but then the numericals will come when the vectors will be expressed in terms of I, j and k. That will be simple for you. Now let me explain what we have been avoiding till now. Suppose I have a point A. I am making the same diagram I made in episode number 4. What is the position vector of A? OA. And what is vector OA? You know what is vector OA? 2i plus 3j. How did I derive it? I drop a perpendicular here, call it as B, So this is called vector OB, and what will be vector OB? 2i cap. This is vector BA, what will it will be? 3j cap. If I drop a perpendicular here, this vector also will be 3j cap. Both the vectors are of same magnitude, it's a rectangle, same direction. Now, did I write x component of this vector as 2i cap? And that time I told you I will explain it later, and the y component was 3j cap. So, what is the key word for finding component of a vector along another vector? Drop your anchors. Now, you want to find the component of OA along x axis pointing in this direction. So, what do? Drop your anchors. You do not need to drop an anchor here, it is already coinciding. Drop an anchor. So, this is called x component of vector OA along x axis. So, this is x component. So, and can you see what it is? 2i cap. Now, you find a component along y in this direction, because it also has to be a vector. So, what is the key word? Drop your anchors. You do not have to drop an anchor here, you drop an anchor from here on this. Let me call it as C, yeah, that is not used. So, vector OC will be y component of the vector. Component of vector OA along y axis will be called as y component, and you see what it is? 3j. So, this is what I have been doing earlier. So, when you express a vector in terms of ijk, again I will tell you xi plus yj, I am wrapping it up and then we will be starting numericals. Every vector is expressed in terms of ijk. When the vector is expressed in terms of I, j and k, very cleverly the two informations are hidden in it. Its magnitude and its direction. Direction is still a mystery. I have not yet told you how to find the direction of a vector expressed in terms of I, j, k, but I have already told you how to find the magnitude of the vector expressed in terms of I, j and k, and also I have told you what is the x component of the vector xi, what is the y component of the vector yj, what is the z component of the vector zk, and here is a example playing with numbers. So, this is the formula you should remember. And what is the x component? Drop your anchors on x axis, the intercept made on x axis is the x component. Component of a vector is also a vector. Alright, xi cap, yj cap, zk cap. There is something called scalar component or projection, we will come to it when the time comes. Alright, so this is component of vector AB along another vector, and we did angle between the vectors also. So, that finishes for the time being the introduction of vectors, more on vectors. So, first 3 episodes were on introduction of vectors. They were little difficult for you to understand in the beginning if you are a non-physics student, but episode number 4 and the present episode number 5 was so easy to understand, so interesting, because we are going to do numericals based on what we learned in episode number 4 and 5. If I know the coordinates of a point, I know its position vector. If a vector AB is given where I know the coordinates of A and B, I can find the vector in terms of ijk. Every vector will be expressed in terms of ijk. If the vector is expressed in terms of ijk, you can find its magnitude as well as direction very quickly. Magnitude you have already learned, it is the square root of the sum of the squares of the coefficients of i's, j's and k's, but how to find the direction, you will have to wait for a while. But before I take up that, we will do some numericals to fortify the theory we have learned so far. Thank you very much for watching this lesson, episode number 5. I hope you learned what I am trying to convey to you. So, I will meet you soon in episode number 6, that will be based on numericals on what we have studied till now. So, have a nice day. We will see you soon in the next episode.